Wow, look at the performance of this VM. Looks good, right? What is up everybody? It's time for another episode of Sam Arcade. Hi, I am Sam and I welcome all of you to my channel. In this amazing video you will learn about KVM, QEMU aka Quick Emulator and figuring out the working of QEMU. And I am going to teach you how to make your VM so blazing fast that it feels like you are running it under a machine, not inside a VM. Let's take a look at how QEMU works. QEMU can emulate various types of hardware components and can incorporate with kernel-based virtual machines. Well, KVM is a part of Linux kernel and QEMU acts as an extension of it, sort of. Actually, it's a lengthy and complex topic to discuss, so we will discuss it when I make a video on GPU pass-through, okay? I know nothing can beat GPU accelerated VM and many of you will suggest me to go with GPU pass-through, but GPU pass-through might not work on a laptop or if your system have only a single GPU. Well, GPU pass-through deserves a dedicated video. Please do not search for what type 1 and type 2 hypervisors are because KVM and QEMU might confuse you. For more knowledge, I suggest you to check the official QEMU documentation. It is a great source of knowledge and you will learn more about QEMU from this documentation, so feel free to check it out. And do not forget to check the guide on disk images and USB emulation. To install QEMU, just type sudo pacman-S QEMU. Then select 2 for QEMU desktop. This package already includes UEFI BIOS with it, so you don't have to download and install the separate OVMF BIOS package. We are going to use QCOW2 image format for our VM. Because QCOW2 is a growable disk image format, which means its size grows gradually. Now we will go to desktop and create a folder named QEMU. And inside this folder, I am going to make another 2 folders named ISO and VM. Inside ISO, there will be ISO images and inside VM, there will be VM's image files. It's time to create our VM's image file. To make an image file, use QEMU-image create-f QCOW2 command and then your image file name ends with .img format and its size. As you can see, our image file is now ready. Now I am going to use the ISO image of Debian Linux for demonstration and copy it to my ISO folder. Now we will create Debian's virtual machine and for this type QEMU-system-x86_64. Let's take a look at QEMU's mind map too, where we will use UEFI BIOS and CPU host, then boot order, and finally QCOW2 image. and we will use OpenGL for video output. Later we will use audio and USB pass-through for demonstration. To use BIOS, just go with dash BIOS with the directory of UEFI BIOS. Then dash enable KVM. Dash M for memory, and I'm going with 5 gigs. Dash CPU host will show you the exact CPU inside the VM as your system, not some random CPU. Dash SMP to allocate CPU threads for your VM. Dash boot for the boot order. And dash CD-ROM to use the ISO image of the distro of your choice. Dash HDA to select the virtual hard disk image file that we created earlier. Last but not the least is dash VGA with VirtIO because VirtIO supports 3D acceleration. And dash display to choose and enable the OpenGL. Look at the performance of this VM and how snappy it is. This is not a Debian 12 Linux installation tutorial. A video on Debian 12 Linux installation with QEMU is coming soon. Now it is time to create a bash script that runs QEMU automatically every time with the required configuration. So touch debian.sh and again name this bash file with whatever you want. I am going with debian.sh. Use the chmod command to convert it into an executable. Read-p will prompt you with a dialog box to fill in the ISO file's location, and then it will store that location in a variable named directory. Again, we will use the same command that we used earlier for this script as well. The only difference is that each of them are on a different line separated by the backward slash. This makes configuring QEMU a lot easier than the traditional one-line route. Enter your ISO file's location, then hit enter. And our script is working without any kind of issue. Let me copy the Debian 12 image file with the Debian 12 Linux pre-installed. So I am going to use that image file for further demonstration. First, remove the -cd-rom line and then put a comment on the read prompt. Now I am going to replace the image with the Debian 12 image file. Get the performance of this VM. But wait, we can further improve this VM's performance with one single trick, and I'm going to show you this trick later. But this trick will only work for Intel and AMD GPU users. As you can see, mine is utilizing an iGPU and performance might seem laggy to you because I am recording and using the VM at the same time. But without recording you will feel 0% lag. To check what kind of audio hardware your system is utilizing, you can use the cat/proc/asound/cards command. Mine is Intel-HDA. Please do not hesitate to search for your audio hardware in the QEMU's documentation. To add audio support to your VM, use -device Intel-HDA for Intel and HDA-duplex will emulate Intel-HDA on the guest using the default audio dev backend. And look, now we have working audio inside our VM. Remember the trick that I was talking about that can further improve the VM's performance? Just type dri_prime equals 1. This command will force QEMU to use a dedicated graphics card. Let me finish with USB pass-through, and then we will see the QEMU utilizing a dedicated GPU. Type LSUSB to see USB peripherals that are connected to your system. For this demo, I am going to pass through my Sony USB drive for this VM. You can pass through USB using host bus and host address, but they usually change when you plug in and plug out a USB device. So we will use vendor ID and product ID because they are unique for each and every device that are connected to your system. Type -USB -device USB -host, vendor ID equals 0x. Your USB peripherals vendor ID, product ID equals 0x. Your USB peripherals product ID. This time use sudo with this script. And look, our USB automatically got disconnected, which means a USB device is now connected to our VM. Look, our DGPU is getting utilized, which means our VM is now using a DGPU for its 3D acceleration. Finally, our USB device is connected with our VM. One last step is to run NeoFetch. That's it for today's video. Make sure to hit like button and subscribe to my channel so you will never miss out my videos. And if you have any kind of feedback or suggestion, then feel free to leave a comment. Thanks for watching.